Hello class, this is Mr. Coy. So I'm just going over SDL 3, the graphing the motion of a cart. So hopefully when you did this you got some data for the time and position of your cart. And hopefully in class you were able to graph it. So I'm going to quickly sketch that. So you have your graph and you should have some of your data. And I'm not going to point or plot all the points, but an idea, your graph should probably have some sort of curve like this. And so now the hard part is, now that we have this position time graph, how do we find velocity? So hopefully you remember this little detail here in the upper right. When we have position, to get there, we start a position, and then if we take the slope, you should get the velocity. So this is a curved line, so it's a little hard to take the slope, but what you can do is look at what segments you have. You can see I'm breaking this graph into segments, and then take the slope or the rise over the run at each segment. So whatever graph you have, you might want to just quickly draw in what makes sense for you, and then you will need your numbers for this. So my graph is a little small, hopefully you made yours bigger, but we can kind of see that we started, that should be my 0. So we started at 0, we went up to about, that's not quite the 25, that's probably like we went up about 20. So we had a rise of 20, or 20 minus 0, and then we went over from 0 to, that's my half second mark, so we went to 0.5 seconds and we started at 0. So that'll get 20 divided by 0.5, which if you put that in a calculator, will get you 40 centimeters per second. So that's going to be your first velocity, 40 centimeters per second. And that was at the 0.5 second mark. Then you're going to take your next one. However, remember, we're not starting at 0 anymore. We are now starting at the 20 mark, going up to about the, that looks to be probably about, that was 25, it's probably about 40, 45. So we go up to about 45, and again, we aren't starting at the 0.5 or the 0 anymore. We're starting here and going over from half a second to 1 second, which will get us again just a segment of 1/2 of a second over 25. If you put this in the calculator, you're going to get 50 centimeters per second. So that's your new velocity. Then we do the next one. So again, these are my numbers. You should use your numbers. But again, we're starting at the 45, and we're going up a little bit faster now. So we're going to be at the 45 to the, looks like probably about the 80. It's okay if these aren't perfect. And again, it goes to 1.5, but we started at 1 second. You'll notice you should, if you're doing this right, you should be getting the same time increments each time, or how much we're dividing by. This is in centimeters, which is why we get centimeters over seconds. 80 divided by 45, minus 45 will get us 35. Divided by will give us 70 centimeters per second. And that was at the 1.5 second mark. And then here, the last one, 2. So it actually looks like it's above 150. So probably at least up from, I'm doing this over here where I have more space. So we started at the 80, and that looks like at least probably the 170 at a very minimal, and again, this is at 2 seconds minus those 1.5 seconds, so we get 0.5 seconds over it, and then 170 minus 80 will get us 90, divided by 0.5 will get us 180 centimeters per second. So that's our last one. Sorry, it's getting messy over here. So that's how you get your first set of data. So I'm going to pause and erase this, so if you did not finish doing it, so finish doing your time and velocity chart, pause it, and then I'll help you guys graph it and do the final stage. Alright, so I have a new chart, or a new graph for the velocity and time, so now we can quickly plot those. So at 0.5, which is right here, we are at about 40, and then at 1, we were at about 50, and then at 1.1 we were at about 70, so it's right here, and at 2 we're at about 180, so definitely some increase going on here, so up here. So this is looking a little more curved than I'd like, which just says I did not take good data. That's okay. We will get better at it. So we do know that at the beginning our velocity was probably 0 because it wasn't moving, so its velocity was 0. And you are going to make this a nice straight line, because hopefully if we did it right and we didn't move our ramp around while the track, or while the cart was moving down the track, we should have a constant acceleration. So that means a constantly changing velocity. And so for the last stage, you can do different parts, but if you did a nice line of best fit, you should only have one slope, so we can see a nice constant slope. So if we start here, go up, and again, pick points on your line, like I'm going to pick this point. Don't use your data points, pick points on your line. So if I go up from 0, and again, we're finding the slope because if we have velocity and we want to look at the acceleration, we need to find the slope of it. So if I figure out how much I increased in speed, so about 125 centimeters per second divided by, it took it about 2 seconds to get here. So 2 seconds up, 175 meters per second up, and that is an S, not a 5. Oh, whoops, 125, sorry. And then over 2 seconds, notice we have double seconds on the bottom, which will get us our second squared, centimeters on top. 125 divided by 75 divided by 2 is 75, if my math is correct. No, it's not. Let me redo that. And actually, 125 divided by 2 is 62.5. So our acceleration should be 62.5 centimeters per second squared. So depending on your ramp, and I just randomly made up these numbers, so depending on your ramp you will have a very different acceleration, but it should be roughly what your partner gets. Please, please, please do these calculations on your own for the practice. Hopefully this was helpful. We will spend a little bit of time going over it, but not too much time, because I would like us to move on and have practice doing additional things. Hopefully this video was helpful. You can contact me on Remind if you're my student. If you're not my student watching this, I hope it was helpful anyway, and it's very messy, and you would know in class because my handwriting's not great in class either. Alright, signing off. Bye-bye. Just kidding. To recap, you get a position and a velocity, and to go from position to velocity, we look at slope. Once we have a velocity graph, if we look at the slope of that, we get the acceleration, because this is in meters. Do the slope, divide by seconds, we get meters per second, divide by time again, and we get meters per second squared. So hopefully you're seeing that there is a pattern to some of this. We're going to start working on area, or how do we go up it. We've been mostly focusing on slope and how do we go down it. Alright, now for real, signing off. Bye.